So today our topic is impulse. Impulse is the very large force acting for very small time into that time interval. In case of impulse, the property होती है, it can change the momentum of the body immediately on that instant. तो very large forces for very small time interval के लिए act करते हैं. Those are impulsive forces, and those impulsive forces into time interval for which they act, that is impulse. For example, F force is acting on the body, F equal to dp vector over dt. Force F is acting on the body, that is dp vector. This quantity is known as impulse. Force into time during which it is acting on the body. If it is variable, then integration of it, that is dp vector, p initial, p final vector minus p initial vector, that is denoted by j, symbol j vector. The impulse on the body for some time interval t equal to change in momentum of the body. It is moment impulse theorem also. Momentum, it is momentum impulse theorem also. Very important one. Okay, in case of impulse, हमें ये ध्यान रखना है, these forces mostly act for very small time interval and change the momentum of the body. Graphically, if the force is acting in one line, body is displacing along this line, then by the nature of the impulsive forces, they increase immediately for very short time interval and come to 0 after very short time interval. In this area between force and time graph, that is f dt, that is impulse with the help of force time graph. Clear? Now we will discuss some problems based on this very important concept. Let us discuss some problem based on the concept of the impulse momentum theorem. Suppose an inextensible string, लाइट स्ट्रिंग इनएक्सटेंसिबल इस तरह से किसी भी शेप में पड़ी हुई है, इट इज नॉट टाइट, देयर आर टू ब्लॉक्स 2m and small m. Two bodies are attached, 2m and small m. Condition is line joining them is this one, and initial velocity is given to this mass v, मान लीजिए v naught मान लेता हूँ. Thread is loose at this time, so it will not move, it will move for some time. When the thread becomes tight, then on this block no force is there, स्मूथ सरफेस के ऊपर रखे हुए हैं, हॉरिजॉन्टल सरफेस के ऊपर. जैसे ही थ्रेड टाइट हो गए तो फोर्स विल एक्ट with sudden, within very small time interval, एक 1 fraction of seconds के लिए 0 था, just after that it becomes maximum. 0 to t tension acts on this block, similarly on this block. So impulse is acting on these two when the thread start to become tight, and after that incident they move together with the same velocity. So what is the common velocity of these two masses? We are going to calculate it with the help of moment and impulse theorem. Clear? मान लीजिए थ्रेड टाइट हो जाता है, स्ट्रेट हो गया 2m और इसकी वेलोसिटी v0. अभी भी टेंशन 0 मान लेता हूं इसमें. आफ्टर वेरी स्मॉल टाइम इंटरवल ये टाइट हो गया. सो टेंशन विल एक्ट लाइक दिस. its velocity changes to v. Its velocity will also be v because thread is inextensible. These two blocks can move together. Inextensible है thread, extend हो जाएगा तो change हो जाएगी इनकी speed. तो because of inextensibility of the thread, blocks will move together when the thread becomes tight. Okay? Now impulse is acting clearly. Movement पहले no tension, after the movement tension acts. So perfect example of these concepts. Important thing is when thread become tight, they move with same velocity because tension is in the same line as that of the motion of the body 1. Okay, let us apply the concepts. मान लीजिए ये डायरेक्शन पॉजिटिव बिकॉज वेक्टर क्वांटिटीज आर इन्वॉल्वड हियर. ये पॉजिटिव, ये नेगेटिव इधर, like this. Okay, on body 2m इंटीग्रेशन t dt, j आ गया, पॉजिटिव आएगा इस डायरेक्शन में. दिस इक्वल टू change in moment of this body, final momentum m into v minus initial momentum 0. It is one equation for that body. For the second one, impulse is acting in negative x direction. Clearly I have taken it negative, so minus j equal to minus t integration dt on body small m. This equal to final momentum minus initial momentum, final momentum of this side positive. So m into v minus initial momentum also in this side, m into v naught. We get these two equations. Let us simplify them. So j equal to 2mv minus j equal to m into v minus v naught. Clear बच्चों? सॉल्व करिए इसको जरा. सॉल्व these two equations. कैसे करोगे? By adding. Very good. So you will get 0 equal to 3mv minus mv naught. So v equal to v naught by 3. क्लियर? तो दोनों बॉडी किस स्पीड से चलेंगी अलोंग द थ्रेड? v नॉट बाय 3 से चलेंगी. अगर मैं 2m को दे दूं यही स्पीड तो क्या होगा? लेट अस थिंक अबाउट इट. सेम सिचुएशन, if I gave v naught speed to 2m mass small m body is at rest, same situation. Let us calculate what will be final velocity. Taking this sign convention, this side positive, this side negative. Okay. When thread becomes tight, let just before becoming the thread to be tight, its speed will be V naught. It is at rest. Just after fraction of seconds, thread becomes tight, tension start to act, मान लीजिए velocity v, because string is inextensible, the speeds will be same. Clear? Okay. Now let us apply impulse momentum theorem. Let us apply on this block. Initially it is at rest, momentum this side negative, so minus j integration minus j equal to minus integration t dt. This is equal to final momentum minus initial momentum. Final momentum is minus mv minus 0. Suppose is equation 1 in this case. Okay, for this 2m mass body, tension this side, impulse will be positive. So plus j equal to plus integration t dt. That will be equal to final momentum. Final momentum is this side, that is negative, minus 2mv minus initial momentum also this side, minus 2m into v naught. Let us simplify these two equations or adding them. On adding them, minus mv minus 2mv minus 3mv, so 0 equal to minus 3mv. Clear? You check this equation, impulse is positive, final momentum this side minus initial momentum also this side, it is negative here. Clear? So adding them, minus 3mv plus 2mv naught, if you simplify it, so final velocity becomes tv naught by 2v naught by 3. Clear? So how the impulse momentum theorem helps us to find the facts, how the laws of physics follow the events. Okay, उसी सिचुएशन में जब स्मॉल m की स्पीड v naught थी, तो फाइनली दे मूव विद v naught by 3. नाउ दे आर मूविंग विद स्पीड 2v naught by 3. क्लियर? ओके, समझ आना बच्चों? गुड. एक और प्रॉब्लम डिस्कस करते हैं बच्चों. ये फिक्स्ड पुली है, स्मूथ, थ्रेड कैसा है? इनएक्सटेंसिबल, लाइट, ब्लॉक का मास स्मॉल m, इट द पेन, इसका मास भी स्मॉल m. तो सारा सिस्टम इक्विलिब्रियम में है, रेस्ट पर है. यहाँ से स्मॉल m ब्लॉक एक बॉडी वर्टिकली आ रही है, इट स्टैक्स टू द पेन एंड आफ्टर स्टैकिंग इट स्टिक्स टू द पेन, चिपक जाती है, एंड द सिस्टम मूव टुगेदर. क्लियर? So our question is, when this block strikes the pen, sticks to the pen, then what are the final velocities of these blocks just after impact? देखिए कैसे. This body strikes with speed v naught से टकराती है, मान लीजिए इससे. Just before स्ट्राइकिंग ये स्पीड v naught है, और टकराने के बाद बतानी है आपको। ओके, क्या क्या होगा? इफ यू थिंक अबाउट बॉल, इस बॉल के बारे में सोचो, इसके ऊपर नॉर्मल रिएक्शन आएगा, mg तो नीचे एक्ट कर ही रहा है, impulse of mg at the time of impact is negligible, or you can say zero, because time interval is very small, the force is constant here, mg is constant. So impulse of mg is neglected, almost zero. n का impulse आएगा, तो due to that impulse, small m, mass of the movement of the small m will change. मान लीजिए फाइनल वेलोसिटी इज v, इधर v स्पीड से जाता है, क्लियर? ऑन द बॉल मैं मान लेता हूं x एक्सिस y एक्सिस, इम्पल्स नॉर्मल रिएक्शन इज वर्टिकली अप, इम्पल्स इज अप, dt टाइम के लिए मान लीजिए मोमेंटम होता है, ये इम्पैक्ट होता है, so you can write here integration and dt vertically up, पॉजिटिव मान लिया मैंने, चेंज इन मोमेंटम, फाइनल वेलोसिटी v डाउनवर्ड्स, so minus m into v for the ball, minus initial momentum is also downward, so minus m naught, mv naught, so clearly ndt equal to minus mv plus m into v naught. Clear? I have taken only case ball. Let us think about pen. In case of pen, normal reaction acts downward, tension increases, impulse of tension is also acting there vertically up, and normal का जो impulse है that is vertically down, and the pen is going downward. Okay, so for the pen, net impulse is n minus t into dt, it is vertically down, which is negative here. This is equal to final momentum of the pen, mass of the pen is m, mv, downwards minus m into v. Clear? Or if you simplify it, you will get n minus t dt integration this is equal to m into v, second equation. Now apply on this block. इस ब्लॉक के ऊपर भी टेंशन का इम्पल्स आएगा, ग्रेविटी का इम्पल्स नेग्लिजिबल, almost zero for that instant when the impact is taking place. So on this block tension increases upward, so t dt integration कितना किधर आया बच्चों? Vertically up. Good. Initially it is at rest, finally it moves with the speed v upward, so m into v minus 0, that is third relation. From all the relations, if you simplify 1, 2 and 3, let us simplify. from 1 and 3, 1 minus 3, 1 equation minus third, we will get n minus t dt integration this is equal to equation 1 minus equation 3. This minus this minus 2 mb plus mb naught. Now from the equation 2, this will be equal to m into v. So simplifying it you will get m into v naught equal to 3m into v. So v equal to v naught by 3. क्लियर. तो ये सारा सिस्टम v naught by 3 स्पीड से चलेगा. इट विल कम डाउन, इट विल गो अप. द परफेक्ट क्वेश्चन फॉर इम्पल्स मोमेंटम थ्योरम. समझ आना है बच्चों? गुड. Let us discuss one problem based on impulse momentum theorem. A wedge of mass capital M is placed on the horizontal smooth surface. A ball is coming vertically downward. It strikes to the inclined face. Let coefficient of restitution be for the ball and this surface of the wedge. Let us calculate velocity of the wedge after impact. It is given small m ball strikes to the face, inclined face with v naught speed. Clear? Okay. When the ball strikes, force between ball and wedge start to act, that is impulse. Impulse start to act on the ball and wedge. Let inclined face of the wedge be smooth. So impulse will be along the normal. So on the small m block, impulse will be in that direction, and on the wedge along the normal, impulse will be in this direction. Clear? Okay. Now after the impact, let velocity of the small m block be in horizontal direction vx component and vertically vy component, and wedge is moving horizontally in this side. Now let us apply impulse momentum theorem on the ball. Initially ball is moving vertically downward in this direction. That angle will be theta. Okay. Now J will be equal to, let that direction is positive for the impulse of the ball, impulse on the ball. So J will be equal to change in momentum of the ball, final momentum, x component this side. So final momentum in the direction of z is small m vx sin theta, vx का sin component आएगा था, प्लस small m into vy cos theta, final momentum minus initial momentum minus m into v naught along the normal. We are taking impulse along the normal. So So component of V naught is V naught cos theta, that side is negative. So minus m V naught cos theta. I repeat it, momentum on the impulse on the small m block is along the normal this side. Let this side be positive. Okay, so final momentum mvx sin theta component plus mvy cos theta component minus इनिशियल मोमेंटम एम बी नॉट कॉस थीटा इधर आएगा, नेगेटिव होगा, माइनस एम बी नॉट कॉस थीटा. सो जे इक्वल टू स्मॉल एम वी एक्स साइन थीटा प्लस स्मॉल एम वी वाई cos theta plus small m v naught cos theta. Let this equation be equation 1. Okay, let us apply on the wedge. Wedge is moving this side. So let us resolve in this case impulse z. This angle will be theta. So z cos theta component this side. It will be balanced from the floor. So z sin theta component, z sin theta equal to change in momentum of the wedge, that is capital M into V minus 0. It is equation number 2. So z sin theta equal to capital M into V, that is equation number 2. Clear? So these two equations are with the help of impulse momentum theorem. Now let us apply Newton's experimental law along the normal. So velocity of separation along the normal. So ball is going with Vx speed and Vy speed this side. So let us calculate velocity of the ball after the impact along the normal. So velocity of separation will be Vx sin theta plus Vy cos theta. Okay. Wedge is moving this side. Velocity is horizontal. Its component along the normal will be V sin theta. Both are opposite, so positive. It is V sin theta. It is velocity of separation along the normal of the ball and wedge divided by velocity of approach. Initially wedge is at rest, ball is coming down, component of V naught along the normal is V naught cos theta. So velocity of approach will be V naught cos theta minus 0, and that is equal to E, coefficient of restitution. So one equation we can get from Newton's experimental law, that is Vx sin theta plus Vy cos theta plus V sin theta equal to E times V naught cos theta. That this equation be equation number 3. Now solving these three equations, we can find out capital V, velocity of the wedge. Now let us solve these equations. From equation 1 and from equation 2, you can put value of J, then you will get capital MV over sin theta, capital MV upon sin theta, this is equal to small m Vx sin theta plus small m Vy cos theta plus small m V naught cos theta. Clear? If you divide this equation by small m, you will get capital MV. डिवाइड करिए बच्चों इसको, कैपिटल एम बी डिवाइड बाय स्मॉल एम साइन थीटा इक्वल टू वी एक्स साइन थीटा प्लस वी वाई कॉस थीटा प्लस वी नॉट cos theta. Let this equation be fourth equation. Now from third and fourth, if you put value of this portion in place of this, you will get capital MB over small m sin theta. This equal to, that is EV naught minus V sin theta plus V naught cos theta. Clear? In place of this हमने क्या रख दिया, Vx sin theta plus Vy cos theta is EV naught cos theta, इधर EV naught cos theta माइनस V sin theta plus ये V naught cos theta. Clear? From this relation you can find out capital V easily. So capital V will be equal to, from that relation, V naught cos theta common 1 plus E from these two relations divided by capital M over small m sin theta plus, it is sin theta here. Clear? So V equal to small m V naught sin theta into cos theta 1 plus E divided by capital M plus small m sin square theta. So it is velocity of the wedge after the impact in a horizontal direction. So in this question we have applied